Good morning, everybody. I hope you had a great Thanksgiving break. Let's go over the bell work really quickly. We're going to take each problem and solve it one at a time. So let's start with number one. And we're supposed to solve each equation. Solving means we're trying to find the value of x, which makes the equation true. In this case, we're trying to set the equation equal to 0, which means we have to find the values of x that make this equation true. So we have to find the x values, where if I plug the x values back in here and do the multiplication, addition, subtraction, division, then I get a 0 back. So let's start with that. We have x times x minus 4 equals 0. Whenever we have a situation like this, we know that we have two things that are multiplying, and the result is a 0. Alright? You guys want some music? Let's have some music. That's too loud. Let's try. Alright. So here we have two things that are multiplying to give us a 0. Now, in this case, what happens is that either one of these things, if it becomes 0, then we get an answer that is 0, because 0 times 0 is 0 times anything is a 0. So we say either x is equal to 0 or x minus 4 equals to 0, which will give us two answers. Well, this one's easy, x equals 0. And my second answer, I just have to solve for it. So how do I get rid of this minus 4? I just add 4 to both sides. This cancels out. This is not equal to 0 anymore. I have to add 4. This cancels out and I get x equals 4. So my two answers are x equals 0 and x equals 4. If I plug in either 0 or 4 into this equation, I should get a 0's answer. Let's check. It's very important to check. So I have my original equation. I'll say x times x minus 4 equal to 0. Let's try 0 first. So I'm going to say 0 times 0 minus 4 equal to 0. 0 times anything is a 0, so 0 equals 0. Works out. Let's try the second solution, which is 4. Again, I'm going to do x times x minus 4 equals 0. This gives me 4 times 4 minus 4, because I'm replacing this x with a 4, equals 0. Well, 4 minus 4 is a 0, so 4 times 0 equals to 0. And that works as well. So we were able to see that this works for us. Alright. Alright, let's look at question number 2. For question number 2, we have x plus 1 times x plus 2 equals 0. Again, if either one of these quantities is a 0, then the result will be 0, because 0 times anything is a 0. So what we say is, we say either x plus 1 is a 0 or x plus 2 is a 0. In either case, it works for me. I subtract 1 from both sides and I get x equals negative 1. I get x equals negative 1. And here I get x equals negative 2. And so I have two solutions, and either one would work. If I plug in a negative 1 in here, I get 0 times something, that is a 0. If I plug in a negative 2 in here or in here, I get 0 over here. So anything times 0 is a 0. So this is my question number 2. Here's question number 3. We have x squared minus 7x equals 0. And so here we don't have two quantities being multiplied. We have a subtraction. So when we don't have multiplication, we have to look to see if we can factor something out. Well, what can we factor out from x squared and and 7x? We can factor out an x. So what's left over? If I had x squared here and if I took out an x, I have left over x. Minus comes down, and then if I take an x out of minus 7x, what do I have left over? Just minus 7. And so that equals to 0. Now this looks exactly like number 1. So I have two things that are multiplying, and the result is a 0, which means that either x is equals to 0 or x minus 7 is equals to a 0. X minus 7 equals to 0 means that x is equals to positive 7. So I have two answers, x equals 0 and x equals 7. Either one would work. Let's look at question number 4. We have x squared minus x equals 6. Now here we don't have the equation equaling 0, we have something equaling 6. Well, we need to make it equal to 0, this equation need to make it equal to 0 so that we can solve it. So how do I get rid of this 6? Well, this is a positive 6, so if I subtract a 6 from both sides, the 6 will go away and it will become a 0. So x squared minus x equals 6. And I'll subtract 6 from both sides, and I get x squared minus x minus 6 equals 0. Now here again we don't have anything multiplying. All terms in here don't have the x, so I can't factor out an x, but I can try and make this a binomial factor problem where the two things that are multiplying are binomials, which means that they have two terms each. So I can ask myself, well, what two things do I need to multiply to get x squared minus x minus 6 back? Well, to get x squared, I have to multiply x times x. Then I need to find two numbers which when I multiply, I get negative 6, but when I add, I get minus 1 because there's a 1 over here. So 2 times 3 gives me a 6. Positive 2 times negative 3 gives me a negative 6. When I add positive 2 and negative 3, I get negative 1. So now I have my factors. The factors are multiplying, which means that either x plus 2 has to be a 0 or x minus 3 has to be a 0. This means that x is equals negative 2 and here x is equals to positive 3. So I have two roots or two solutions. Either one would work. Alright, let's look at number 5 really quickly. X squared minus 80 equals 20. Now here we have an x term, a term without an x, and then another term on the other side without an x. So if I were to just get all the non-x terms on one side, then I could just take the square root of this x squared and get an x. So I'm going to add 80 to both sides. And so I get x squared is equals to 100. I will take square root of x squared, and similarly I have to take the square root of 100. When I take a square root of a number, the result is positive and negative, the square root. So I get x equals to, what's the square root of 100? It's 10. So the result is plus and minus 10, which means x is equals to 10 and x is equals to negative 10. I have two solutions. And that's the end of our bell work. I hope that you were able to take notes and make corrections as needed. Continuing on, we're going to be working on, we'll be working more with quadratic equations and using quadratic equations to solve real world problems. All right, thank you.